Welcome back, engineers. We are discussing architectural styles, and in this video let's look at the next style, which is microkernel architecture style. I hope you're ready. Let's get started. So to understand this style, let's take an example of a bus terminal. So let's say this is our bus terminal. Generally a bus terminal has several facilities, the basic functionalities and so on. So let's say our bus terminal has these facilities. It has arrivals, it has departures, so which is taken care by some scheduling system, right? And we have some platforms assignment, so when the bus comes in, it needs to go into certain available platform so that passengers can get in and bus can leave the platform, right? And then there are some communication channels established, basically like a reception or a help desk or an information desk where we can actually go and see the arrivals and departure scheduling. Maybe there are some TVs which are displaying this information and so on, right? And some basic facilities like restrooms are available in the bus terminal. Okay, so these are the fundamental things that are generally available in a bus terminal, but passengers may want to have more facilities than this, right? So maybe the bus terminal company or probably the government may want to give provisions to different facilities depending on the need for that particular city or that particular population and so on, right? So let's say I'm adding certain features like this. It's the same bus terminal, but I'm adding certain extra functionality to the same bus terminal so that the passengers can benefit from it, right? For example, I can have private bus counters. I'm opening the bus terminal to private buses, let's say. So the private bus people can have their own counters, their ticketing systems and so on. Maybe I want to add a food court and more people can have their own stalls inside the bus terminal, right? So we can have food stalls. Maybe we can add additional parking for the consumers, right? And probably also a taxi stand so that it will be helpful when they leave the bus terminal, they can take a taxi and go to their desired destination and so on, right? Maybe there can be a passenger lounge for customers who are waiting for a bus to actually sit down and relax and maybe grab a drink and so on, right? And maybe there can be a foreign exchange service. If this bus terminal is an international bus terminal, maybe people who want to travel across countries and there is a difference in currency, people can exchange money here, right? Maybe there is a separate luggage store for people who want to just dump their luggage, go around, come back, pick up the luggage and go on to the next bus, right? And maybe there is a tourism office which helps passengers know about the local tourism facilities or the information about popular tourist places or how to travel to those places and so on, right? So these are some additional facilities that are surrounding the bus terminal that was handling the basic core functionality. So this is a proper analogy for a microkernel architecture system, right? So this is an example from the real world, which is non-tech related, but in the tech world, there are plenty of examples as well, right? For example, the browsers that we use, Firefox, Google Chrome, Safari, etc. The core functionality is to browse the web, right? But we can add so many functionalities to it by installing extensions, right? We can add a Grammarly check, we can add probably a screenshot tool or so on. We can probably add a dictionary, we can add an AI agent and so on, right? So there can be many extensions like this. The operating system itself can be a good example. The core operating system does basic functionality of file storage and handling, but we can install so many apps through the app stores and the play stores and so on, so we can extend functionality. So those are like the extensions to the core operating system. And the IDEs that we use, VS Code, Eclipse, IntelliJ, whatever, we have the core system, which is simply a text editor, right? All IDEs are simple text editors. But by installing extensions, we can add more functionality to these IDEs so that we get more functionality out of it, right? So that's the whole idea behind the microkernel architecture style. Now let's see the details of this architecture. So this architecture is also known as the plugin architecture, right? So as we have discussed in the examples before, there is a core system that takes care of the basic handling, the core functionality of the system, and the plugins can be registered onto the system and they can be independent and they can add additional functionality, right? This is the whole idea behind the system. Let's go deeper into the system and try to understand the features. So the first feature is the core system itself. So what does that core system box do? It has the minimum functionality to set up the system and keep it up and running, right? The basic nuts and bolts. And it also gives us the happy path, right? The basic functionality, for example, the IDEs that we spoke about, we should be able to do basic text editing in a text file, basically, right? So that's the happy path. So that's the idea behind a core system. It takes care of the happy path. And now let's look at plugins. So each plugin is an independent standalone system that can work on its own, and it is plugged into the core system, right? So it works with the core system to enhance or update the functionality, but they are independent and standalone systems, and they can also have their own data store if need be, but generally it's the core system that talks to the central database. But if need be, plugins can also have their own little data stores and read and write data from there. Okay, and then we also have a registry, which is not shown in the diagram, but it is also required. This is where the core system checks about what plugins are currently registered into my system and what is their status, what is their information, and so on. So this can be a simple map. It can be a reference to a plugin name against a plugin object and so on. So this is a simple registry. And then we have contracts. Contracts can be through interfaces or adapters. So contracts are very important in this architecture, especially because all plugins need to follow a certain level of implementation. Although each plugin can have its own style of implementing it, but there are certain things that they must adhere, right? For example, all the plugins must provide an entry point to actually invoke the plugin, right? And probably all the plugins will need to export some kind of an output, right? And those type of things are defined in these contracts, right? Especially in the interfaces. And if a plugin is completely different from the central contract, it can have its own implementation, but there should be some kind of adapter to convert that implementation into the core system's functionality, right? In some way, a contract needs to be established so that the plugins can work with the core system. Okay, so those are the main features. Now let's look at certain topologies that are possible with this architecture. So we have seen that there is a core system and then there are central plugins. Now the core system in this architecture can be broken down into either a technical breakdown or a domain driven breakdown, which is like a business breakdown, right? So this core system can be broken down into layers here, the layered architecture style we have spoken about before. So the core system can be a layered monolith, or it can be a domain driven modular monolith like this. So each component can be a different module, maybe payments or notifications or authentication and so on, right? So in different ways we can break down the core system, but this entire system is deployed as one unit in most cases, and that's why this is still a monolith architecture. Okay, this is not a distributed one. So you can argue that this plugin itself can be deployed separately, and that creates a distributed architecture, and then we are opening up all the possibilities about asynchronous communication, fault tolerance, failure modes, and so on, and it just complicates the whole system, right? So to keep it simple, the architecture suggests that you deploy this whole thing as a single deployment unit. So different topologies are possible with this architecture. It is quite flexible in that nature, and we can keep on adding plugins to enhance the functionality of the core system. Okay, now let's see the trade-offs. So this comes with the pros and cons, which are quite similar to the modular monolith layered architecture that we have seen before. So it is simple, it is cost effective, and this can be either domain or technically partitioned like we have seen before. And we also get reasonable testability advantage here because all plugins can be independently tested and the core system has minimal functionality. So we get some testability advantage here, and deployability is slightly advantageous because the plugins can be created and registered independently, and these are the main two advantages of this architecture: modularity and evolvability, because we can break down the core architecture into different modules if need be, and evolvability is obviously through the plugins. You can keep on adding functionality to our core system, right? So these are the main advantages, and the cons are very similar to the other ones. We don't get enough scalability because we cannot independently scale each plugin on its own. And fault tolerance is a little bit of an issue here. If the core system goes down for some reason, all the plugins will be unusable, right? And finally, elasticity is also a challenge because of the centralized nature of the system. We cannot have the central core system scale up independently by, maybe adding additional pods into the Kubernetes cluster and so on, because the whole system needs to go as a whole. Okay, so that is a challenge in this architecture. Okay, so those are some of the pros and cons. If you have any questions, definitely let me know. I hope you found this video helpful. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I will see you in the next video where we will discuss another architectural style. Thank you so much for watching. I'll see you in the next one. Cheers.